These questions are about finding the limit. When you plug in 1/3 into top and bottom, 9 times 1/3 squared minus 1, the top one has 9 times 1/9 minus 1, that's 1, 1 minus 1 is 0. And same thing, if you plug in 1/3 in the bottom, you will see that this also gives you 0. Okay, you can just calculate that. So you might say this limit is 0 over 0, but that's not allowed because 0 over 0 is what we call an indeterminate form. It just means that it can turn out to be any limit. So writing 0 over 0 is really not doing anything at all. So what do you do when you have 0 over 0? The first thing that you should try is to see if the top and bottom can be separately factored. And in fact, if the top and bottom are polynomials, there's a theorem called the Factor Theorem, which says that indeed, if you get plugged in something and you got 0, that means the top and bottom are both divisible by x minus 1/3. Or another way to say it would be 3x minus 1 will be a factor of both. Okay? So just keep that in mind. Let's try to factor top and bottom. First, the easy one is 9x squared minus 1. What's that? That's 3x squared minus 1 squared. So difference of two squares says 3x minus 1, 3x plus 1. That's how you factor a squared minus b squared. Right? A squared minus b squared is a minus b times a plus b. So that's what you get on the top. On the bottom, you don't know how to factor this, but we kind of have an idea that it should have 3x minus 1 and you should have something else here. The reason I say this is because we plugged in 1/3 to the bottom and you got 0, right? And if that happens, then you should have this one, this term, this factor by a factor theorem. See, what is 3x minus 1 when you plugged in 1/3? 3 times 1/3 is 1, 1 minus 1 is 0, right? So when you plug in 1/3, you're going to get 0 here, and that's why this will be a polynomial that gives you 0 when you plug in 1/3. That's basically the gist of the factor theorem. And then you have to figure out what should be in here. Well, to get 3x squared, I better have x. X times 3x gives you 3x squared, right? And to get plus 2, I have to multiply negative 1 times negative 2. So that's the factor, and you can indeed multiply this out to check that this does give you this. See, 3 times negative 2 is negative 6, negative 1 times x is negative x, so negative 6x plus negative 1x gives you negative 7x, and it does give you 3x squared and 2 because we made it like it. I mean, even if you didn't know that it should have a factor of 3x minus 1, you should be able to just look at this and try to factor this by using methods you learned in pre-calculus or before. I mean, you learn how to factor these trinomials in Algebra 1, so you should know how to do it. Okay. Yeah, and if you want to learn it, if you forgot it, then search up factor by grouping, factoring trinomials by grouping, and you're going to find a bunch of videos or online articles on how to do it. Okay, so now that the top and bottom both have 1/3, 3x minus 1 in there, so I can cancel them, and now I can plug in 1/3 without causing a 0 over 0 problem. Now it's 3 times 1/3 plus 1 divided by 1/3 minus 2. 3 times 1/3, they cancel to give you 1, so it's 1 plus 1 on the top. 2 is what? 2 is 6 over 3. So I made common denominators, so this becomes 2 over negative 5 over 3. Now we have a fraction inside the fraction that has to be simplified. How? Multiply 3 top and bottom. Then 2 times 3 gives you 6. whereas 3 cancels, you get negative 5 on the bottom. So the answer is negative 6 over 5. Okay, next question. Now this one looks pretty similar, but let's see. If I plug in 2 squared minus 9 gives you 4 minus 9, which is negative 5. Okay. And if I plug in 2 in the bottom, 2 squared minus 5 times 2 plus 6, that's 4 minus 10 plus 6, which is 0. Okay. So this time when you plug in 2, you don't get 0 over 0. You get negative 5 over 0. Okay, so you get negative 5 over 0. In this case, it's not an indeterminate form. It actually means that while the top gets closer and closer to negative 5, the bottom becomes close to 0. And when you divide a finite number by something that's very, very close to 0, it becomes very large. So it's going to be like positive infinity or negative infinity. So in that case, the limit does not exist. Okay? So in this case, the limit does not exist. However, when the limit does not exist, you have to make sure if there's something more can be said about this. Does it actually go to positive infinity, or does it go to negative infinity, or is it the case where the left limit goes infinity and right limit goes to negative infinity? That can happen also, right? You have 2. When you approach 2 from the right, it might go to negative infinity. When you approach from the left, it might go to positive infinity. Or another case would be as you approach from the left, it could go down to negative infinity, and this way it's going to go up to positive infinity. If any of these happen, then you cannot say the limit is infinity or negative infinity. You have no choice but to say dn. dn will be the only answer you can write. And this last condition here is basically asking you to check whether that's true. Okay, so let's try to see what happens if you take the left limit when x is sent to 2 minus of x squared minus 9 over x squared minus 5x plus 6. Well, the bottom can be factored as x minus 2, x minus 3. And the reason I'm factoring is because it's easier to evaluate this in a factored form. You can do the same thing for the top, but the top goes close to negative 5, so I'll just leave it. I know this is going to be negative 5. The top becomes negative 5. I really need to be careful about the bottom. That's why I factored it. Okay. All right. So once you see how I plug in numbers, you're going to see why I factored it. I plug in 2 minus minus 2. So 2 minus means like 1.999, right? Something that's close to 2 but slightly less than 2. So if you subtract 1.999 minus 2, that's going to be negative 0.001. So it's like close to 0 but less than 0. Okay. And then 2 minus 3, that's negative 1. So I have negative 1. And then the top will be negative 5. Now, this is like negative 0.0001, that's what I said. But you multiply negative, so that's going to be positive. So you're going to get a positive number in the bottom, a positive number that's close to 0. That's what you're going to get in the bottom. Whereas on the top, you're going to get negative 5. Now, if you don't understand these symbols and if it's confusing you, what you can do is you can just really plug in 1.99 and see what happens in the top and bottom. Well, see, if you plug in 1.99 in the top and you plug in 1.99 minus 2, 1.99 minus 3 in the bottom, then the top one, well, this is close to 2, so the top will be close to negative 5. It will be something like negative 5. This will be negative 0.01. This one will be, that's like 2 minus 1, that's close to negative 1. So that's like approximately this value. This would be approximately that. And you can easily see that negative times negative is positive, so you're really like dividing negative 5 by 0.01. Okay, that's what I mean by this. Okay, so you have that, and then you get a negative divided by positive, so that would be a negative value, and because if you divide 5 by 0.01, something like that, it's going to be a huge value with a negative sign, so in the end this is going to be positive infinity. So I just established that the negative limit, I mean the left limit, is negative infinity. Now on the other hand, let me get some room here. On the other hand, if I try the right limit, let's try the right limit, you get limit x going to 2 plus of x squared minus 9 over x minus 2, x minus 3. Then if it's 2 plus, then 2 plus minus 2 will be slightly bigger, right? Still, the other one is 2 minus 3 is negative 1, 2 squared minus 9 is negative 5. So negative negative is positive, so you get 5 divided by 0 plus, which is positive infinity. Okay, so this is what we just found. If you approach 2 from the left, it's going to go down to negative infinity. If you approach 2 from the right, it's going to go up to positive infinity. So because the left and right does not match, the answer has to be D and E. Okay, and we had to do so much work just to figure out that's D and E, not one of these, but that's inevitable. You have to do it this way. Oh, okay, so this next question is basically that. We just solved it, so I guess we can skip it. If you want to write down the solutions, it will be limit x going to 2 minus of x squared minus 9, x minus 2, x minus 3. So when you plug in 2 minus minus 2 is 0 minus, times negative 1, negative 5. Negative 5 over negative 1 is positive 5, so you have 5 divided by 0 minus, so that's going to be negative infinity. Okay. That will be a very good thing to write on the exam. Okay. It's very convincing, and all the work is totally clear. Okay, let's look at this next question. This time you're plugging in negative infinity. So x is a very, very large number with a minus. And we learned that you divide by the highest power of the denominator. The highest power in the denominator is x squared, so I'm going to say limit x going to negative infinity, and you're going to divide top and bottom by x squared. So 9x squared divided by x squared, minus 1 divided by x squared, 3x squared divided by x squared, minus 7x over x squared, plus 2 over x squared. And you get 9, you get minus 1 over x squared, you get 3 minus 7 over x plus 2 over x squared as limit x goes to negative infinity. Okay, so just think about a really large number like a million. Okay, so if you plug in a million here, if x is like negative million gives you squared as a positive trillion, right? So 1 over trillion, that's almost like 0, right? Same thing here. 7 over a million, that's almost like 0. 2 over a trillion, that's almost like 0. So as you make x to be negative of a really, really big number, these will become 0. So the only thing you end up with is 9 over 3, which is 3. So that's the answer. Okay, now this time you have e to the x. So how do you deal with e to the x? Well, you have to know what is e to the x as limit x goes to negative infinity. Well, see, if you have a negative power in the exponent, that's same as 1 over e to the infinity, right? But what is e to the infinity? Well, e is about 2.7. So if you do e squared, that would be like more than 8, I would say. And if you take e to the 10th power there, that's already bigger than 1,000. So e to a very, very big number, so I want to say e to the 10th power would be bigger than 1,000. So e to the very, very big number would be infinity, right? So it's going to be 1 over infinity, which gives you 0, okay? So knowing that e to the x will go to 0 when you send x to negative infinity, I will tell you that these two things would be basically 0. These e to the x will converge to 0 as x is taken to negative infinity, so you end up with 4 over 3 as the answer. It's that simple. Now let me show you another one that's very similar to the one that we just did, except that this time we have x going to positive infinity. Now I said that e to the infinity is infinity, so really it's e to the infinity here, e to the infinity here, and overall it looks something like negative infinity over infinity. Because e to infinity is infinity, there's a minus sign. However, this is again what we call an indeterminate form, so it really doesn't help. It doesn't really help us knowing this. What you really need to do is to divide by the highest power of the denominator, but since it's not a polynomial, we can't do that. Just remember that e to the x is higher than any other polynomial. Like, you can take any x to the nth power and e to the x. If you compare the values of this, it will always turn out that e to the x is bigger than this for some big X. Okay, so because of that, you can kind of think that e to the x is like a very, very high order polynomial. That's just a figure of speech. This is all I want to say. So what you want to do is, this time the principle that you have to divide by the highest power of the denominator will be applied as dividing by e to the x. So I'm going to divide everything by e to the x. And that gives you limit of x going to infinity of 4 over e to the x minus 1 over 3 over e to the x plus 2. Now when you send x to infinity, we just learned that e to the infinity is infinity, right? So you end up with 4 divided by infinity minus 1 over 3 divided by infinity plus 2. But any finite divided by infinity, that's 0, right? So these are both 0, so you have 0 minus 1 over 0 plus 2, which is negative 1/2. So that's the answer. The answer is negative 1/2. Okay, again, a similar problem. I see x cubed is the highest power, so I divide top and bottom by x cubed. That's what's going to happen if you divide by x cubed. 5x squared divided by x cubed would be 5 over x. 7x divided by x cubed would be 7 over x squared minus x cubed. That's what I did. I divided every term on both the top and the bottom by x cubed. And because all of these will become 0, see, if x is 1,000,000, 5 divided by 1,000,000, that's 0, right? So the same thing happens in all of these. So you end up with 0 over 2, which is 0. And that's kind of obvious because the bottom increases much faster than the top. Now, if you didn't do this, and if you just wrote down, well, this is positive infinity, the bottom is positive infinity, it just gives you an indeterminate form. It doesn't really tell you much, other than you have to do more work. But what you learn here is that although both top and bottom are infinities, this overall is equal to 0 because the bottom infinity is x cubed kind, which means it's going to increase to infinity much faster than the top. That's why this becomes 0. So that's an intuitive way of understanding why you get such a thing. Okay, again, you're taking x to infinity, so we must be dividing by the highest power of the denominator. In our case, you're dividing by x. So limit x going to infinity and 5 minus 9 over x. That's what you're going to get in the bottom. But on the top, it's a little complicated. I don't know how to deal with dividing by x because, see, because you have the square root, this entire top is a single term. It's not 3 terms, it's just a single term because everything is taken the square root of. So when you divide by x, you can't divide these individual terms individually. You have to put x once for all. Now, to figure out what this is, you will need to further investigate this top. First thing you want to do is to take the square root of x squared and the bottom is still 5 minus 9 over x. And you can do this because square and square root cancels, right? So that's the same thing as x. Only if x is positive, but x is positive because x is sent to positive infinity. If x was sent to negative infinity, then this gets actually a little more complicated. Anyways, you have this, and then you also know that square root of a over square root of b is the same thing as square root of a over b. So because I have square root both in top and bottom, you end up with limit x going to infinity of a single square root, and now you have 4x squared plus 9x plus 3 over x squared divided by 5 minus 9 over x. Okay, now you have 4x squared divided by x squared. What's that? That's just 4. 9x divided by x squared is 9 over x. 3 divided by x squared is 3 over x squared. So what I did was I took this fraction and I made it into 3 fractions. It's the sum of this over this, this over this, this over this. So those 3 fractions are written. And now you have, now you can send x to infinity. All of these that have x in the denominator, they're going to go to 0, right? So you end up with square root of 4 divided by 5, which is 2 over 5. Number 12. Compute and simplify the difference quotient f of x plus h minus f of x and use it to find the derivative using the limit definition. Okay. I think a lot of people have trouble figuring out this difference quotient because they don't know how to figure out f of x plus h. Okay. And unless you really are sure how to get f of x plus h from here, you should follow my method. And if your final answer is different from mine, that's because probably you messed up in this, exactly this part, figuring out f of x plus h. Okay, so let's try that. First, to get f of x plus h, it has to be in 2 steps. First, copy down the function that you have, but every time you see an x, you leave it open, put a blank, and put a parenthesis, okay? So that's what you need. And then, once you have those blank spaces open, you're going to write x plus h in there. X plus h, x plus h, x plus h. And this can be further calculated by using the square formula. X plus h squared is square the first, twice of the product, plus h squared. This is another common part where people make mistakes. See, x plus h squared is x plus h times x plus h. So you have to do the FOIL. If you FOIL this, you get exactly this, right? Okay, so now you have x plus h minus 11, and that's negative 5x squared minus 10xh minus 5h squared plus x plus h minus 11. Okay, so with this calculated first, and actually that's what I would recommend. First calculate f of x plus h separately, and then try to do this, okay? F of x plus h minus f of x over h would be this horrible thing, negative 5x squared minus 10xh minus 5h squared plus x minus plus h minus 11 minus f of x, which is negative 5x squared plus x minus 11, and then you're dividing by h, right? Now if you look closely, you'll see that there are common things between these two, so that means you can cancel things, okay? So you can cancel negative 5x squared with negative 5x squared, you can cancel x with x, and you can cancel negative 11 with negative 11. Now the end result is that you end up with negative 10xh minus 5h squared plus h over h, and since every one of these are divisible by h, you can divide by h and get negative 10x minus 5h plus 1. And then finally, what you can do is you can send limit h goes to 0 of negative 10x minus 5h plus 1 equals to negative 10x plus 1. And the reason I'm doing this limit is because the limit definition says f prime of x is limit of h going to 0 of this difference quotient. The difference quotient has the limit f prime of x, so I have that this is our f prime of x. Okay. So the answers are 2. This should be answer 1, and so that's an answer. That's an answer here, and that's also an answer. Now let's try to do the second one. Again, f of x plus h has to be done in 2 steps. First, copy the function like this, and then into the vacated space you put x plus h in both places. Okay, therefore my difference quotient will be f of x plus h minus f of x over h, which is 1 over x plus h minus 1 over x over h. And now you have to simplify. The way you simplify, well, this requires simplification because you have a fraction inside a fraction. And when you have fractions inside a fraction, you should always try to simplify it. And the best strategy for simplifying fraction inside a fraction is to look at all the denominators. There's x plus h as the denominator. There's also x as a denominator, and just multiply the denominators top and bottom. So you multiply this. Okay. Now let's continue. Then this times this is going to be x plus h times x over x plus h, and this times the second one will be minus x plus h times x over x over h times x plus h times x. Now you don't want to multiply the denominator because often the factored form is the simplest form. So if you multiply something top and bottom and the bottom one is entirely a factored form, you don't want to multiply them out. Okay, so just leave it like that. And now I see that for these things on the top, because we multiplied by the denominator, the same stuff will cancel. So you get x minus x plus h divided by h times x plus h times x. And x minus x is 0. You have negative h on top. H times x plus h times x. And I see now the top and bottom can be divided by h. So if I divide top and bottom by h cancels, and you end up with this final answer, which is negative 1 over x plus h times x. Okay, so that's our answer for the difference quotient. Now, since it's asking for using the limit definition, find f prime of x. F prime of x is limit h going to 0 of the difference quotient. And since we computed the difference quotient and we got this, we're going to just quote it. limit h going to 0 of negative 1 over x plus h times x. And now that h is set to 0, since h is set to 0, you just get negative 1 x times x, which is x squared. So that's our second part of the answer. Okay, so these two are answers. Question 13. Suppose we have two functions fx and gx. Given that f of 2 is 1, f prime of 2 is negative 2, g of 2 is 2, and g prime of 2 is negative 1, answer the following. Okay, what is fx gx prime at x equals to 2? Well, if you want to, I don't want to use red. Let me see. If you want to differentiate this, and you want to evaluate at x equals to 2, you first have to differentiate this, and you realize that these are two functions multiplied as a product. In that case, you must use the product rule. It's not an optional rule. It's something that you must do. So it's a product, you must use the product rule, and that tells us that you have f prime of x, g of x, plus f of x, g prime of x. And then you're plugging in 2. Okay, you might feel a little nervous because I don't know what fx is, I don't know what g of x is, but since it's set to evaluate at x equals to 2, let's just plug in 2 and see what we get. F prime of 2, g of 2, plus f of 2, g prime of 2, and you get, well, f prime of 2 is given as negative 2, right? So thankfully, although we don't know the values of f prime, we don't know the function f of x, we're given the values, and that's just enough to solve this question. G of 2 is 2, f of 2 is 1, g prime of 2 is negative 1. So you end up with negative 4 minus 1, which is negative 5. Okay, you can do the same thing for the next one. Again, it's derivative evaluated at some value, and because this is a fraction, you want to write it as f prime of x, g of x, minus f of x, g prime of x, over the denominator squared. And then you have to plug in x equal to 2. So again, it's the same story. F prime of 2, g of 2, f of 2, g prime of 2, g of 2 squared. Okay, just apply the quotient rule. I hope you memorized it. And just quote all the values from the top. It's negative 2 times 2 plus 1 times, not plus, sorry, it should be minus 1 times negative 1 over g of 2 is 2, so it's 2 squared. That means you get negative 4, negative is plus, so plus 1 over 4, so that's negative 3 over 4. Okay, next, what is fx squared prime at x equals to 2? Well, this time fx is nested inside a square function, right? So when you differentiate this, you need the chain rule. You think of this as a big X squared. X squared differentiates 2x, right? So you think of it as 2 times big X, but that big X is f of x, right? Times the derivative of the inside function, so you take the inside function and you differentiate it. You make a copy of the inside function and put prime there. And then you plug in x equals to 2, which gives you 2 times f of 2 times f prime of 2. And that's 2 times 1. F of 2 is 1, right? And f prime of 2 is negative 2. So negative 4 is your answer. Now finally, this part D, is D continuous at x equals to 2? And the answer is yes, because, yes, because g prime of 2 exists. It's negative 1, right? So g of x is differentiable at x equals to 2. Now, if a function is differentiable, then it has to be continuous. Any differentiable function is continuous. It's not true the opposite way. You can have a continuous function, but if you have a sharp turn, then it might not be differentiable. But if it's differentiable, we know that it has to be continuous. So remember this. A differentiable function has to be always continuous, and also the tangent line always has to be defined, so you cannot have a sharp turn. So we know that differentiable functions are continuous, and it never takes any sharp turn. And that's why we can say that g of x is continuous at x equals to 2.